Now let's talk about speed limit. Speed limit is a type of question where you're usually given a point on the function. We're starting with the function f of x, and we're giving the derivative f prime of x. We're limiting it. So in our case, we're limiting it that it is always greater than -1 and always less than 3 on the interval from -3 to 6. So the question that we're looking at when we're doing the speed limit, we're only looking at the interval between -3 and 6, because outside of that interval, we really don't know what's going to happen, so we can't say anything about f of x. So let's go ahead and see what it looks like and what speed limit really means. So the first thing I'm going to do is I'm going to plot our initial point, f of 1 equals 1. So that's just going to be the point 1, 1. And I'm not going to put units on the y-axis. I'm just going to kind of plot the points and write down what the coordinates of each point is. So now what we're going to try to do is figure out what are all the possible points what are all the possible values of f of x on this interval from -3 to 6. So what we know is that the change of f of x, that the slope of the tangent line cannot be less than -1 and cannot be greater than 3 at any point on that interval. So what we're going to do is we're going to look at the worst case scenarios. The worst case scenario is going to be that the derivative is either 3 or -1. So now let's look first at the derivative being 3. So we're starting at 1, and let's look at the right side of the graph from this 1, from x equals 1 to x equals 6. So x equals 6 will be this 2, 3, 4, 5, 6. It'll be this somewhere along here, and we want to figure out where this will reach if f prime is equal to 3. So to get from 1 to 6, we're moving 5 units across, and every unit across we're going up by 3. So 5 times 3, that's 15. So we're going across 5 units, up 15, and since we're starting at an initial value of 1 comma 1, we're going to have to add 1 to 15. So we're going to get some value over here. So 15 plus 1, that's 16, so it's going to be 6 comma 16. And just to recap, what I did was I figured out the change in x. The change in x was 6 minus 1. And then I just multiplied that by the maximum slope and added that to our initial y value, which was 1. So 15 plus 1, that gave us the 16. So now let's look at the other worst case scenario, which is that the derivative is -1, that f prime of x is -1. Well, if f prime of x is -1, we'd be moving over still 5 units, and if we're moving over 5 units, we're moving down 5 times 1 units, or we're moving up 5 times -1 units. So we just multiply the derivative by 5, and that's the change in y. So since we're starting at a y value of 1, and we're going down 5 units, that'll give us a y value of -4. 1 minus 5 is 4. So that's, let's say that's going to be somewhere over here. And that point's going to be 6 comma -4. So this right here, these 3 points, tell us a lot about the function. If the derivative is 3, so this is the worst case scenario, the derivative is equal to 3 from x equals 1 to x equals 6, we'd be just getting this line right here, the line connecting these 2 points. And if the derivative was -1, we'd be getting this line connecting these 2 points. So we don't know what the derivative is. We just know that these are the limits. These are the absolute worst case scenarios. There's no way that we can get a point out here. Because to get a point out here, we would need a slope. If we connected this, we'd need a slope that was greater than 6. Now, I'm not saying that the slope is constant throughout the whole, throughout the whole domain, but at some point, if we want to get this point, let's say the slope started off like that, to get to that point, we'd suddenly need a really steep slope that would be greater than 3. So there's no way to get this point out here. Let's just pick some point over here. Now, there are many, many ways that we could get this point over here. We could have a constant slope connecting this point. We could have a slope that's starting off a bit steep and then getting steeper and steeper and steeper, as long as the slope of this part is not greater than 3, because that's a limit, the limit on f prime of x. So we could get this point over here. We could get this point over here. We could get this point over here. We could get any point inside this. So what the speed limit is telling us is that the possible values of f of x from 1 to 6 are all these. So there are lots of different questions that can be asked using speed limit. I could ask you, if x equals 6, what are the possible values of y? And then we could easily say that y has to be between -4 and 16, because it'd be all these values. So this is just half of the question. Remember that we know that f prime is bound to these values on -3 to 6, and we're starting at 1, 1. I'll rewrite that. So now let's go to -3. So to get from 1 to -3, we're going back 4 units. So once again, let's look at the first worst case scenario, which is that f prime is 3. If we're going back 4 units, that means we're following this line, and we're going down 4 times 3, which is 12 units. And we're starting at 1, at a y value of 1, and we're going down 12. So we're going to go down up until we hit this -3. And we know that this point is going to be 1 minus 12. So it's going to be -3, comma 1 minus 12, which is 11. -11, sorry. So that's going to be the first worst case scenario. And the second one is if the slope is -1, then we'd be following this line up until x equals -3. If we calculated that, we're going back 4 units. So we need to multiply our slope by -4. So -4 times -1 is just 4. And we're going to be adding that to our initial value of 1. So 1 plus 4 is 5. So we get the point -3, comma 5. And now we can say that from 1 to -3, these are all the possible values of f of x. And that's the speed limit, because now we have our domain from -3 to 6, from -3 being here, 6 being here, and all this shaded region, these are all the possible values that f of x can be between -3 and 6, and that's what the speed limit tells us. And once again, there are lots of different questions that can be asked using this idea. This is pretty much just understanding that since the maximum the slope can be is 3 and the minimum it can be is -1, these are all the possible values of f of x. And that's it.